All right, welcome back here to our seismic monitoring presentation for the T3 Alliance Seismic Studies course. Now, we want to talk about types of seismic data and how that data is, visualized, because really only one type of seismic data, it's the ground motion data. But how do when we see it, how do we understand it? And there are two main, types of data visualization that I want us to get familiar with. And those are a seismogram or waveform, which, as you see here, is just the actual, ground motion, the actual shaking that happens. And then, of course, when, if it gets shakier, then you see that both the positive and negative velocity here goes up, and then it gets shakier, and then it goes back down. That's the one type. And that waveform that's because it's the energy waves, right, that are moving through the waveform. You can see other types of waveforms that look very similar to this. If there's an acoustic boom, if there's like a sound boom up somewhere, sometimes those sounds look very similar because it's all energy, right? And similar to sound, there are also frequencies of the shaking, right? So if it's like a lower frequency shaking, just like if it's a lower frequency sound, it might be a little more rumbly. I like to think of low frequency like one of my favorite artist singers there. His name is Johnny Cash. Because you're mine, I walk the line, right? Low frequency. And that's where you see here, earthquakes are often low frequency. And low frequency also takes longer to go away. Like it rolls in and it kind of stays around a little longer. And on this graph, and I'll talk more about it in a second, you can see, low frequency, and then up here is higher frequency. It means it's just faster shaking, right? Because energy comes in waves. The low frequency is just a little bit longer of waves. It just takes longer, bigger waves, takes longer to go up and longer to go back down. And the higher frequencies, right, it's much faster how fast it's vibrating. And you can see that, down here is like, 1 to 10 hertz. Looks like it goes through 10 to 50 hertz. So down here is like 1 or 2 or 3 hertz, right? And that's where a lot of this earthquake's energies come in. And hertz is just a way of measuring how jiggly, that is. And, you see in this spectrogram, the color of the spectrogram is how strong that frequency is, the intensity of the frequency. So you notice that over here, before the earthquake gets there, there's not too much, strong shaking. There's not too much, there's not too much going on. There may be this one little shaking frequency happening right here at 20 hertz or so. What do you think that is? It could be something like a air conditioner. So what do air conditioners do? It could be something like a fridge, or maybe it's a heater, right? A boiler going, and that's creating some frequency of. But then, there may be something down here. It's lower frequency. And then the earthquake happens, boom, all this shaking, and you can actually see where the first wave hits, and then it gets brighter here, it gets stronger. That's where the second wave is. And anyway, let's look into that. So seismograms or waveforms, what are these things? And as we said, they are the actual how much the ground is moving up and down, left and right, depending on what component you're looking at, right? Is it the up and down component? Is the north-south component? Is the east-west component? And they started out, this is the original way to look at seismic data because of those original seismographs that would actually have the physical pencil moving, up and down. So what you can see is there's a really kind of standard way of looking at earthquakes that earthquakes release waves. The first wave, it usually releases a P wave. The second wave is an S wave. And there may be a Raleigh or Love wave that are even bigger waves. So those important ones are the P and S waves. And you can see the difference in those because the P waves go faster, so they arrive first. The S waves come later. And you can see that on these seismograms, right, waveforms. I think we use the word waveforms because we don't confuse ourselves with seismograph, seismogram, so the waveforms, you see, oh, there's a P wave, there's an S wave. There's a P wave, there's an S wave. And then the other waves might come later and shake a little differently. But there are also other types of things you can see with waveforms, right? So here it looks like you can see the various types of signals, waveforms that you can get from different types of things. So here in the middle, it looks like tectonic earthquake beneath Mount Rainier. And I'm pretty sure this seismograph where these waveforms come from is from Mount Rainier in Washington. So tectonic earthquake beneath Mount Rainier. So you can see that there's not really a difference between the P wave and the S wave because it happened so close that energy just boom happened and boom earthquake, and then it goes back to being like that. Tectonic earthquake near Mount Rainier. So there you can see a little separation in this P wave, boom, and then S wave a little bit later. Distant earthquake. See, when it comes from really far away, there's much less of a strong signal, but you can kind of still see the boom, and then it takes a long time to roll through. See how it's kind of flat, and then long time to roll through. You can also see other things like a rock fall. Some rocks fell down, and the seismograph detected it, and you can see that. Glacier sliding noise, right? When a glacier is moving around, you can detect that with the earthquake. Those are called ice quakes. And then, there are also debris flows, right? So if some big landslide or flow happens, that might cover that over a length of time. So there's a lot of really cool things you can see just with the seismograms. And then one of my favorite parts about looking at seismograms is you can see something and be like, well, that could be an earthquake, I don't know. But you also can look at spectrograms, which are looking at that frequency. So in the middle here, I'll just talk about one more thing that's still a seismogram, but it has another name, which is a helicorder plot. And that is seismogram, so waveform data over 24 hours, over a 24-hour time period. And you can see here that this is a screenshot from a helicorder plot of data view, which we'll explore in a little bit, over a 24-hour period. And I think this was set up originally because that's how long a one of those drums would, seismograph drums would go for 24 hours. So you just switch it and then look at that. And it still is like that when you look on digital data. And using this plot, you can tell a lot of things. Like you just scan it immediately. Obviously, this is nighttime because there's not too many people, movements happening. Oh, what's that right there? You can kind of see there's a little bump and then another bump over here. That's probably an earthquake. And this is, you could actually, using this helicorder, you can go back and find different dates and look at different things. So it's a really cool option for when you're exploring data. So those were the waveforms. Now let's look at spectrograms and how cool spectrograms are. And the reason spectrograms, I really would like all of us to become familiar with them, is because sometimes you see a waveform that just doesn't really make sense. You're like, oh, maybe it could be an earthquake, but I don't know. And there is this option that exists with the program we'll use mostly called Data View, that's connected to Raspberry Shake, where you can just switch the waveform view to a spectrogram. And I was saying earlier, right, that spectrograms display the frequency and intensity of shaking on this graph, and over time, of course. So the y-axis here is frequency, x-axis is time, and then the color is the intensity of the shaking. And you can see, when you can kind of tell when there's an earthquake because it kind of looks like this. It looks like a little, right triangle, right? It's like straight up, and then it kind of has a tail. See that? It like tails off. And you can see that over here too. This is another earthquake. There's P wave and S wave, here there's P wave and S wave, and you can see those in the spectrograms, and they're pretty low frequency, right? The shaking isn't as high sometimes when something else happens, you might just see a little blob of middle frequency energy, like over here in the middle. Earthquakes almost always have low frequency energy and it tails off. And that's pretty important when you're exploring things. What do you guys think this is? That looks funky, huh? Like it's quiet and then all of a sudden I think I just made that up, but that might be how it goes. And it is actually the beginning of a washing machine cycle. Think about it. What is a washing machine? And that's what that looks like. And you can see how the frequency happens there, and it's very cool. And this is another example of an earthquake. How you can see the triangle and the low frequency, tail off. All right, so now I'm going to switch over here for a quick second to look at data view. And this is what I want you to explore, and your assignment, which will also be posted here, or what I would like you to do for this after watching this video is go and explore data view and Raspberry Shake and find an earthquake for me. And then post a screenshot below and tell me, where you think it is. And I don't know, just that's the thing to do. So to go to see data view, this is data view right here. dataview.raspberryshake.org, but I'd recommend actually getting there by starting from station view, which you can just type in, stationview.raspberryshake.org, and the link will be underneath this video also, and it'll load your inventory. It might take a little while if you're at an internet spot that's tough, but you go there and then say, all right, here I am. I see all the stations up here in Alaska. Oh, it zoomed me in on Anchorage. I want to look at Cordova and see what earthquakes have happened in Cordova in the last few days. So I click on Cordova and then say, I wait. And how did I click on Cordova? Sorry. I'm here. I click on Cordova and then I come over to, this is where it talks about it, right? And I click on this C24-hour plot. That will bring me to data view. And once I'm there on data view, then I can look around and be like, do I see any earthquakey things here? And this is in a classroom, so there's a lot of people moving around during the day. You can see how it gets kind of noisy. At nighttime, there's some interesting things that happen. Like, look, this looks like it's at almost midnight, and there's something that turns on. See that? Whoa. All of a sudden, it's kind of quiet, and then all of a sudden, let's see what that is. So I just know that something's happened. This little waffle icon turns on the spectrogram, and I can see that, whoa, it went from this kind of quiet line going through there to all of a sudden, this weird thing. It could be that the boiler turned on. Could be that all sorts of things turned on there in Cordova. But it looks like there weren't any earthquakes that day. Maybe if I click on a few other of these little bumps, it'll look like it. But see how I clicked on this little bump there. And is that an earthquake? I click on this. No, because it doesn't have that really nice, right triangle with a tail thing. So I'm going to go back a few days. I'll go back to yesterday. It doesn't really look like much. I see that same thing turned on here. I'm going to go back one more day. I'm just exploring and trying to find an earthquake. This is kind of what I hope that you guys will want to do in a little bit. Whoa, something weird's going on there. Yeah, that's crazy. I'm going to keep going back one more day. Huh. Yeah, so one more time. I'm having a hard time finding an earthquake. So I might actually go to a different seismograph. I might click on one of these over here in Anchorage. Anchorage has a lot of earthquakes. So I'm going to click on this one here in Anchorage. And to do this assignment that you'll do, you can go to any. You can look at any earthquake you want. I mean, any Raspberry shake you want to. It doesn't have to be the one from your school, because many of you don't have it set up yet, even, and that's okay. So I'm going to click. Oops, I'm going to click right there on the one in Anchorage, see 24-hour plot. And then, oh my goodness, I just open it up, and the first thing I see is this earthquake right here that happened. It's like last night, and I'm pretty sure it's an earthquake because it has a P wave and S wave, but I'm going to click on this toggle waffle spectrogram, and boom, look at that earthquake. Boom, nice. And you see how it has that little frequency there? Something is buzzing in that house. Yeah, and I can click on other little things that happen at nighttime. Look, there's another little earthquake that happened right there. Happened only a couple hours ago. You can see how it's kind of tiny because, you know, it's not that strong compared to the other one. But yeah, that's how you explore data view. You can do that wherever you want, all over the world. If you want to go find an earthquake that happened over here in Japan, you can go find an earthquake that happened wherever you would like to. All right, that's the end of that video. Another 15-minute video, so thanks for watching. It's pretty exciting. All right, take care, guys. Stay shaken.